This section we are going to be using exponents and talking about more specifically exponents when it comes to multiplication and what we do with those exponents. So first here it's telling us to fill in the blanks. I'm going to do the long version of exponents. So this big number 5 right here, that's called a base. The little 2 or squared right there, that tells us how many times we want to multiply the base by itself. So when we see 5 squared like this, that means 5 times 5. So there is 5 squared. 5 to the 8th, let's bring the times down there, that means 5 times 5 times 5, all these 5s 8 times. And basically what we're trying to simplify is how many total 5s do we have written down. And if you add up all the 5s, in this case you should have 10. So this is kind of the long way of writing exponents out. And then you can count, as long as you write them all out like this, you're guaranteed to get them correct. You can write them all out, count them up, you know how many 5s there are. There is a shortcut though. When we multiply like bases, so 5 and 5 are our bases, and those are the same exact base. When we multiply like bases, we add our exponents. So 2 and 8, 2 plus 8 is 10. Here we have 10 5s written out. We also have added them. 2 plus 8 is 10. Let's go to part B here. Looking at the base, I have like bases. All of those are x. When you multiply like bases, we add our exponents. And then 3 plus 5 plus 10 is 18. Coming down here, I see m and m. Those are like bases. But here's a 2 and here's a 5. Those are not like bases. Those coefficients, those numbers in front, check out what we did here. We put those in parentheses off to the front. We are going to multiply those numbers separately. So when you have numbers in front that are different, like 2 and 5, those are different numbers, we are going to multiply those out differently. And 2 times 5 gives us 10, so that's where this 10 is coming from. So the numbers in front, when they are different, do not apply to the exponent rules. The only times we pay attention to the exponent rules is when our bases are the exact same, like m and m. And when we multiply like bases, we have, or we can, add our exponents, which gives us 10m to the 12th. Again, if we write all of this out, you're guaranteed to get it right. So you can write out 2 times m 10m's times 5 times 2m's. So now it's kind of like combining our like terms. Well, 2 and 5, 2 times 5 is 10, which we got there. And if you count all of those m's, you will end up with 12 m's, which means m to the 12th. Either way will work to show your work and get these answers correct. So using what we did in example C above, we are going to solve this. So first, I am going to separate my coefficients, those numbers in front. The reason I am doing that is because they are different. They are not like bases. Here, my y's, those are like bases. So I'm going to multiply by y, and just like I did up here, I'm going to put 4 plus 7. And now I have 3 times 5, which gives me 15. And then when I combine my exponents, when I add 4 plus 7, I get y to the 11th. So my answer is 15y to the 11th. This question, does x to the 8th times x squared have the same value as x to the 5th times x to the 5th? Explain your answer. Well, I'm going to explain it by showing my work. So x to the 8th times x squared equals, I have like bases here, and when I multiply like bases, I can add my exponents, which gives me x to the 10th. Now here I have x to the 5th times x to the 5th. Again, I've got like bases, and when I have like bases, or when I multiply like bases, I can add my exponents, which gives me x to the 10th. So yes, they do have the exact same, because when we simplify them, they both give us x to the 10th, because when we multiply like bases, you add your exponents. Let's write that down. When you multiply like bases, you add your exponents. There we go. That's good to remember. All right, now it's starting to look a little bit different. We have parentheses inside something, a power to another power, an exponent to another exponent. This 2 on the outside tells me to write whatever is inside the parentheses twice. So I have 10 to the 3rd times 10 to the 3rd. And this is the long way of doing it. 10 to the 3rd means 10 times 10 times 10. That's 10 to the 3rd, or 10 cubed. I have another 10 cubed. So I have 2 10 to the 3rds multiplying by each other, which leaves me, when I count all of these 10s up, it leaves me with a total of 6 10s. So that would be 10 to the 6th power. All right? Again, this is the longer way, but it's going to allow you to get the answer correct rather than trying to do the shortcut way and not quite showing our work as much. So let's look at what this is telling us to do. When we have the power to a power, when we see parentheses and we have an exponent on the outside, it's almost like distributing that exponent inside the parentheses. And when we distribute, that means to multiply. So a power to power means we're going to multiply our exponents. 2 times, or 3 times 2 gives us 10 to the 6th power. So see how we got the same answer either way we did it? Again, you can do these either way. Again, a power to a power here. It's like we distribute our exponent, and when we distribute, we multiply. So here I have x to the 12th. Right here, same thing. Power to a power, we multiply our exponents. So this gives me a to the 30th. Now let's use what we just found out to simplify this expression, power to a power. So we multiply our exponents, which gives us g to the 54th power. All right, now here, I'm going to show a little bit extra. So I have 3 terms inside my parentheses. All 3 of these terms have exponents. Just because they are not shown does not mean they are not there. If exponents are not shown, that means we have an exponent of 1. So there, it's 3 to the 1st power times c to the 1st power times d to the 1st power. All of that squared. Now, if we write this out the long way, again, guaranteed to get it right. Here, I'll write this out the long way. This squared means I'm going to write this twice. Now I'm going to count how many 3's I have. I have 2 of them. 3 squared. How many c's do I have? I have got 2 of them. How many d's do I have? I have 2 of them. 3 squared is 9. There is my correct answer. Or, if we recognize we have a power to a power, we multiply our exponents, but we have to be careful. We multiply exponents by other exponents only. So I am going to distribute this 2 on the outside, the exponent on the outside, to only the exponents on the inside of my parentheses, which 2 times 1 is 2, so this leaves me with 3 squared times c squared times d squared. Simplify that. 3 squared equals 9. 3 times 3 is 9. And notice we get the exact same answer. So we have to be careful because we multiply exponents by other exponents only. So let's try this again. I have 3 terms within my parentheses. This 5, I do not see an exponent on that 5, so I'm going to go ahead and put 1 in there. When there is no exponent written, we know that has an exponent of 1. And now I'm going to distribute my exponent to the other exponents only inside the parentheses. 3 times 1 is 3, so I get 5 cubed. 3 times 2 is 6, so that gives me m to the 6, and 3 times 3 is 9, so I get n to the 9th. The only thing I have left to do is simplify this 5 to the 3rd power, which is 5 times 5 times 5, which equals 125, m to the 6th, n to the 9th. Just like we did above, I'm going to write out all the terms inside the parentheses with the exponents. This 2 does not have an exponent with it, which means there is an exponent of 1. S to the 5th, t to the 9th, all of that to the 4th. So here, power to a power, I distribute. And I multiply exponents by other exponents only. That's it. So 4 times 1 is 4, so I have 2 to the 4th. 4 times 5 is 20, so it's s to the 20th. 4 times 9 is 36, so that's t to the 36th. Okay, and then we do 2 times 2 times 2 times 2. So 2 to the 4th. Here's what 2 to the 4th means. Okay, 2 times 2 is 4, right? 2 times 2 is 4. 4 times 4 is 16. So I'm left with 16 s to the 20th, t to the 36th. And that's what we do when we have exponents, or that's what we do with our exponents when we multiply.